Hello and welcome. Today, we are going to unlock a kind of superpower, the ability to see the future. Well, sort of. We're going to dive into how we can turn a bunch of raw data into really powerful predictions using a fantastic tool called the scatter plot. So how do we do it? It really all starts with a question. You've got lists of numbers, all these different data points and information, but how do you make any sense of it? How do you get that data to tell you its secrets? Well, that is the puzzle we are solving today. To help guide us on this journey, let's meet Marcia. She is a super creative entrepreneur, and she's been making and selling her own cards. For a whole year, she's been tracking everything about her business, but right now she's kind of just staring at a big pile of numbers.
I mean, look at all this. She's recorded how many hours she works versus how many cards she actually makes. She's tracked her spending on supplies and all her equipment. She has all this amazing information, but she really needs a way to see the patterns that are hidden inside.
So, this brings us to our first big step. Because before we can predict anything at all, we first have to actually see the relationship in the data. And for that, we have the perfect tool. The scatter plot is going to be our hero here. It's this special kind of graph that takes two different pieces of information, plots them on a chart, and just lets us see if there's a connection between them, a pattern we'd never spot just by looking at a list.
And every single scatter plot has two main characters. Down on the horizontal x-axis, we have the independent variable. Now, this is the thing you change, like the hours Marcia works. Then, on the vertical y-axis is the dependent variable. That's the thing you measure, like the number of cards she makes. Its value depends on the other one. See how that works?
So once we plot our data, we're looking for something called correlation. And that's just a fancy word for the story the data is trying to tell us. Is there a relationship? Which way is it going? And, how strong is that connection really?
So when we look for a correlation, there are pretty much three main stories our data can tell us. A positive correlation means as one thing goes up, the other thing goes up too. A negative correlation means that as one goes up, the other one goes down. And hey, sometimes there's just no clear pattern at all.
Let's make this feel a little more real. A positive correlation. Think about this. The more you study, the higher your test score usually is. Negative, the more car payments you make, the less money you owe on that car. And no correlation? Well, I'm pretty sure the number of pets you own has absolutely nothing to do with your shoe size. Okay, so we've plotted our data, and we can actually see a relationship. That's fantastic. But a cloud of dots, while it's helpful, isn't quite precise enough for making exact predictions. To do that, we need to find the single, clear trend that's hiding in that data. And this is where the line of best fit comes in. It's a straight line that literally cuts right through the middle of our data points. Now, it might not hit every single dot perfectly, but what it does is capture the overall pattern in the most accurate way possible. You can think of this line as math's way of drawing the most accurate summary of your data. It's not just a guess. It's a precisely calculated trend that gives us a really reliable model to work with. So how do we know how well our line actually fits the data? For that, we get a score. It's called the correlation coefficient, or we can just call it R. This one single number tells us exactly how strong the relationship is and what direction it's going in. Now, the R value is always going to be somewhere between -1 and +1. Think of it like a confidence score. An R value that's close to 1 means we have a very strong, very confident positive relationship. Close to -1, that's a super strong negative relationship. But an R value near 0 tells us the pattern is weak and we probably shouldn't trust it for predictions. All right, now for the magic. Our line of best fit, it's not just a line, it's a recipe, it's an equation. And with that equation, we can start making actual concrete predictions. And you know what? The process is surprisingly straightforward. You just plug your data points into a tool like a graphing calculator or Desmos. Then you ask it to do something called a linear regression, which is just the fancy term for finding that perfect line of best fit. The calculator does all the heavy lifting and boom, it gives you an equation. That equation is your crystal ball. For instance, let's go back to our studying example. After running a regression, you might get an equation that looks something like this. This formula now perfectly describes the relationship between the hours you study, which is X, and your test score, which is Y. And this is where it gets really powerful. We can now ask questions about data we don't even have. Like, what if you want to get a perfect score, 100%? Can our equation tell us how long we should study to make that happen? Oh, absolutely. We just take our goal, a score of 100, and we plug it right into the Y spot in our equation.
And now, we just have a simple algebra problem to solve for x, which, remember, is the number of hours we need to study.
And voila! After doing the math, the equation predicts that studying for about 9.36 hours could get you that 100%. We just used past data to make a specific, really useful prediction about the future. I mean, that's the power of this whole process.
So here's the crucial point. We've gone on a journey, right? We started with just a messy pile of numbers, and we've turned it into a tool for making actual decisions. Let's just do a quick recap of how we did it. So here it is, your 4-step toolkit for prediction. It all starts when you identify what you're changing and what you're measuring. Then you graph it so you can visually see the story. After that, you calculate the line of best fit to get your magic formula. And finally, you predict, using that formula to explore all kinds of new possibilities.
And this is the key insight. The exact same method we used for test scores works practically everywhere. Marcia can now use her own equation to predict how many cards she can make next week. Scientists can model how quickly a solution will cool. I mean, from business to biology, this toolkit is just incredibly versatile.
So just remember, a scatter plot is so much more than just a graph. It's a tool that helps you find the story that's hidden in the numbers. It turns math into real, actionable insight. And now you know exactly how to use it. You've totally got this.